Welcome to part 3 of the Conservation Innovation Grant Insight webinar series. The purpose of these webinars is to share insights into the nutrient-led third-party technology evaluations that were conducted under our 2020 NRCS Conservation Innovation Grant Award. I'm Corinne Brown, Analyst of Sustainability Research and Initiatives here at Nutrient, and in today's webinar, we'll be exploring vibratory separation screen technology. Nutrient was founded in 2015 to help farms identify ways to reduce their environmental footprint while making it economically viable to do so. Our forward-thinking members include milk cooperatives and dairy organizations representing nearly all U.S. dairy farmers. In 2020, Nutrient received nearly $700,000 from the NRCS to evaluate 15 technology systems and practices with the aim to demonstrate how these systems reduce the environmental impact of dairy manure with a focus on water quality. Our goal is to improve access to EQIP funding for innovative technologies under Conservation Practice Standard 629 and other associated standards. Garnering universities nationwide, we collect samples, document the results, and produce comprehensive reports. These reports will be shared with the NRCS and the dairy industry to encourage the adoption of sustainable dairy practices. With that, I'm excited to introduce Jeff Porter, Technical Advisor here at Nutrient, an agriculture engineer with extensive background with the NRCS, where he served as the leader of the National Animal Manure and Nutrient Management Team.
Thank you, Corinne. Greetings, everyone. I also want to thank all of you for joining our webinar today. For this evaluation, we looked at the performance of a Sweco HX round separator. 2 units were installed on the Kilby Dairy located in Maryland. The University of Delaware served as a third-party evaluator for this project. They also developed a performance report for Nutrient. Now, I know this is a very busy screen, but this shows the various processes that occur on this dairy. First, that shows that there are a number of unit processes needed to meet the goals and the objectives for this operation. It also illustrates how complex it can be to deal with manure management. Let me give you just a brief overview of the manure management system on this dairy. Since the operation beds with sand, and because of its abrasive nature, it is important to remove as much of the sand as possible prior to other waste separation processes. The captured sand is reused for bedding. Next, the liquid is sent to the Sweco vibratory screen to remove the large coarse solids. These large solids then go to a screw press to remove excess liquids. The resulting solids are composted and used on farm or sold. The liquids coming from the Sweco go to the anaerobic digester for energy production. We'll talk more about this in a few moments. Liquids from the screw press and digested effluent from the digester flow into the holding pond where it can be land applied and used for flushing the sand lanes. This operation looks to optimize their waste management system and utilize as much of the material as possible for on-farm use and for developed markets. Now, even though the Sweco vibratory screen is a small part of the overall manure management system, its role cannot be understated. For the on-farm dairy industry, the Sweco vibratory screen is used primarily to separate solids from liquids. The three-dimensional vibratory action enhances this separation process. This vibratory action also helps to keep the screen clean, reducing downtime. It can be used for various applications, ranging from coarse solid separation to fine solid separation. And how it is used is dependent on the dairy's goals and objectives. Units can be operated individually or in series where they might be stacked or used in parallel. There are a number of different screen sizes, which adds to the flexibility of this technology. It is also used in separating dry products. Now, I have heard about vibratory screens for a number of years, but the only thing I ever saw was a schematic of one in publications. And that very same image was apparently used in all of the references that I had reviewed. But over the last few years, I have seen these vibratory screens installed on several dairies. Here we see a cutout of a Sweco vibratory screen separator. And as the unit vibrates, the larger material moves to the oversized discharge, while the liquids and smaller solids flow through the screen and out of the undersized discharge. Separator efficiency and throughput can be adjusted with the ProGlide linear weight system. Also, up to 4 drums can be placed on a unit for providing additional separation fractions. Now, when looking for a waste separation system, as mentioned earlier, the technology or technologies selected are to meet the objectives of the dairy. Does one have the right feedstock for the system to operate properly? Will it flow through the system properly? Are the correct screen sizes used? What are the different products going to be used for, the larger coarse solids and the liquid effluent? The Sweco units should be under roof and protected from weather. Manure slurry should not be frozen as it will not separate properly and will likely damage the screen and the separator. Proper and adequate storage should be provided for each of the products that are produced. Even though not as critical for the Sweco system, most sand should be removed from the waste stream in that it can potentially increase wear and tear on gears, screens, and shafts. With the tangential action of the screen, it is essential that all operation and maintenance requirements are followed to keep the unit running efficiently. Now, as mentioned before, there are a number of applications for the Sweco separator. For the dairy where this evaluation was performed, the coarse solids were removed and the resulting effluent went to the anaerobic digester. Since these larger solids take longer for the microbes to break down, they were removed to help improve digester performance. It also allowed them the ability to create a compost product with the larger solids. Additionally, since the anaerobic digester had no direct agitation system, these larger solids would have a tendency to settle, reducing digester capacity and requiring periodic cleanouts. For another dairy, the Sweco separator, they were used in this particular case to remove material like animal hairs and other fines that pass through the coarse solid separation system. This helped to improve the performance of ultrafiltration that was used on this farm and to reduce the amount of downtime required for backflushing the filters. The large number and various screen sizes also adds to the versatility of this technology. Now that you have a little background of this technology, let's take a look at some of the results from the evaluation of the Sweco vibratory screen. For this evaluation, 5 manure samples were collected 3 times a week over a 16-week period. Even though this review focused on the Sweco separator, samples were also taken from the screw press. Flow rates were estimated using a bucket test. All of the samples were sent to the A&L Great Lakes Laboratory for testing. Results were reviewed and analyzed by the University of Delaware. As mentioned earlier, the Sweco screen was used to separate coarse solids from the waste stream. Liquid effluent from the Sweco flowed to the anaerobic digester for energy generation. The coarse solids portion went to a screw press. The solids portion was still relatively high in moisture content, around 90% or so, but had a lower moisture content than the original waste stream. The higher solids content helped the screw press operate more efficiently. The material shown in this image comes from the solids component of the screw press. As will be seen in the upcoming slides, primary nutrient content in the screw press solids were generally higher than the Sweco solids, whereas the nutrient content of the liquid effluent from each separator were very similar. Let's take a look at some of those results. When looking at the solids content of the 2 separators, The numbers for the SWECO unit are similar to the manure inflow rates. The main reason for this is the relatively high moisture content of the SWECO solids. Screw press solid content was about 75%. Organic nitrogen and phosphorus tend to bind more with manure solids and would be expected to be higher for the screw press, as we see that they are here. Now, for the liquid effluent, both the SWECO and the screw press primary nutrient values were very similar to the inflow content. Now, this would be expected since less than 8% of the material was actually removed with the separation technologies. This supports the reason for using the SWECO unit to separate the coarse solids from the liquid effluent entering the anaerobic digester. This separation had little to no impact on biogas production, especially since they were also adding food waste to the system. And it also reduced operation and maintenance issues that could have resulted from accumulated solids. For this operation, there are several benefits for utilizing the SWECO vibratory screen as part of their waste management system. Removal of coarse solids can help with nutrient management. Solid manures can be transported longer distances at a lower cost. This can help to address those areas that may be high in nutrients, such as phosphorus. The SWECO system likely enhanced the separation process of the screw press by providing an effluent material with a lower moisture content. Flush systems are generally higher moisture, and manure thickening can improve the separation process. The material provided to the digester can more readily be broken down by the microbes to generate biogas. Operation and maintenance costs can be reduced. With the coarse solids removed from the waste stream, less agitation and plugging will occur with land application of the manure. As with all mechanical systems, regular operation and maintenance should be performed for the SWECO unit. Follow the guidance provided in the Operation and Maintenance Handbook. For this dairy, there are many unit processes working in conjunction for the system, and each process should be inspected to ensure that they are operating properly and that flow rates are maintained. Planning is an essential element for a successful waste management system. Understanding the various components and functions is important for the system to operate properly. Evaluating the rate of return on the investments of the technologies chosen and their expected performance should be a part of the planning process. On this dairy, there are multiple environmental benefits for using the SWECO vibratory screen in conjunction with the other technologies associated with the manure management system. From a water quality standpoint, removal of solids allow for more efficient application of the manures. Center pivot and drag hose systems can be used more effectively with less plugging. Solids can be transported longer distances at lower cost and be applied to fields that may not normally receive manures. Using recycled flush water reduces the amount of fresh water that is utilized on the dairy. Removing solids from the waste stream helps to lower methane emissions. Removing the coarse solids helps with the anaerobic digester in allowing it to function more effectively and further lowering the methane levels through energy generation. Soil health is also improved by adding organics to the soil from manure applications. Some of the key takeaways from this review, they include solids can be used for making compost. Nutrients in the solids can be transported longer distances at lower costs. Removal of solids from the liquid stream help with flush water, improve application of manures, and reduce plugging of irrigation systems. Anaerobic digester performance is enhanced, and with the removal of coarse solids, solids accumulation is drastically reduced. So now let's look at some of the costs associated with the SWECO vibratory screen system. For the unit that was evaluated for this review, the HX48 round separator. The cost is around $18,000 at the time that it was purchased. Piping and other appurtenances would also need to be considered in the cost of installing a unit. According to SWECO, the average annual operation and maintenance cost is around $3,000, which includes screen and gasket replacements and the lubrication kit, which eliminates the need for individuals to oil and grease the unit. It is also estimated that the motor will need to be replaced every 5 years or so. By following the operation and maintenance manual, it will help keep the unit running more efficiently and more effectively. By utilizing various separation technologies such as the SWECO vibratory screen, there is the potential to generate additional revenue. For this dairy, the separated solids are composted, where some are used on farm and others are sold. Even though not a revenue stream, the reduced core solids in the waste stream reduces operation and maintenance costs for the digester and the holding pond. The liquid can be land applied more efficiently with less plugging of irrigation nozzles. The more solids removed from the liquid can also improve flush system performance. In relationship to the anaerobic digester, the renewable energy can be used on farm and sold to the energy grid. There's also the potential for carbon credits to be earned with the reduction in methane emissions. When looking at waste separation or other technologies for manure management, there are a series of questions that should be answered before moving forward. Now, this is not going to be an exhaustive list, but they will provide a good starting point. Climatic conditions can impact the manure consistency. Should the technology be under a roof to protect it from weather concerns? Is sand bedding used? If it is, how is it being addressed? Sand removal may be necessary for technology to operate properly and to improve its longevity. Should solid separation technologies be implemented? What would be the benefits of adding solid liquid separation? How will the solids be used? What impact will solid separation have on the uses of the remaining liquid effluent? Will it improve land application efforts, improve flush water quality, or provide other benefits? Can the use of manures help to reduce the amount of commercial fertilizers that are used? What impact will it have on soil health? If solid liquid separation is utilized, is adequate storage available for all components? At this time, I would now like to return control back to Corinne.
Thanks, Jeff, for your valuable insights on the vibratory separation screen technology and nutrient sig evaluation. Now let's walk through some of the various resources Nutrient offers. We have many experts on our team who are happy to spend time with you as a farmer, cooperative, or other industry stakeholder looking to learn about additional on-farm sustainability practices or to hear more about Nutrient. The Nutrient website, www.nutrient.com, houses many resources, one of those being the Nutrient Solutions Catalog. This is an online collection of solutions including manure additives, NRCS practice standards, and hundreds of service and technology providers. Nutrient's Resource Library is a place where audiences can find a compilation of webinars, peer-reviewed articles, white papers, and more. Nutrient's blog hosts various articles and posts about recent dairy industry happenings, specifically pertaining to dairy sustainability. You can also locate various webinars on the Nutrient LLC YouTube channel, including 2 other videos part of this webinar series on dairy composting and decanter centrifuge technologies. Nutrient's quarterly newsletter is also a great resource to learn about Nutrient's latest updates and dairy sustainability news. Use the QR code on your screen to subscribe to our newsletter for timely updates and industry news, as well as access Nutrient's contact form to get in touch with us. If you're curious about the 14 other Nutrient SIG technology evaluations, visit Nutrient's SIG webpage where you can view project materials such as vendor snapshots, evaluation summaries, comprehensive reports, webinars just like this one, and informative videos. Do note, though, that evaluations and deliverables will be added to the web page as they're completed, and not all technologies will include all of those listed deliverables. I'd like to give a very special thank you to our partners on this project, including the USDA NRCS, our university research partner, University of Delaware, for their work evaluating this technology, Kilby Dairy for allowing the evaluation to take place on their farm, and Sweco for collaborating with Nutrien as the vendor of the evaluated vibratory separation screen. Okay, now we'll jump into our Q&A. Accompanying me will be speaker Jeff Porter. Hi, Jeff. Let's dive into
Greetings.
this first question.
Fantastic.
So, first question, why perform an evaluation on a vibratory separation screen, or in general, what sparked the interest in including this technology in nutrient SIG evaluations?
Well, Corinne, it's kind of interesting because I mentioned it a little bit during the presentation part. I had seen images and figures, or I guess one figure of the
Right?
vibratory screen in all the publications I've looked at, and I just wondered, what in the world is this piece of equipment? What is this technology? And then once we started doing some site visits, once we started doing some of the other evaluations, I started seeing this piece of technology, this vibratory screen, being used on various dairies, and I said, that's what I've been looking for. And I really felt it was really something that we needed to have an evaluation on, because really all we had was a picture. We had very little information on what the vibratory screen was used for and where it was being used. And now that I was seeing it used at multiple dairies around the country, I thought we need to do an evaluation of this to provide more information for producers who may be interested in this technology. Maybe they're dealing with some of the issues that we discussed during the presentation that would help them in some of their separation technology, separation issues and concerns that they have that might help improve the performance of maybe some of their other separation technologies or some of the other I guess other kind of technologies that they're using for their dairy to help improve the performance, to improve maybe to come up with some additional byproducts to help with anaerobic digesters or some of those other technologies that are out there to help improve the performance of those particular uses that the dairies are looking at today.
Now, if somebody were to implement a vibratory separation screen on their farm, would it be difficult to integrate that into an existing manure system?
Well, you're probably going to hear this answer a lot. It depends.
Yeah.
There's just a lot of things that come into play. Number one, does it meet the goals and objectives of the dairy? Is it going to help improve the performance of maybe the existing system, or is it going to improve the performance of the dairy itself from the waste management standpoint? One of the things is it takes up space. So would you be able to find the area for this piece of equipment to be added? And if you are adding this piece of equipment, what what is its main purpose? Is it just to get the core solids out like we did on the dairy, the main presentation that we did for this? Or do you have other purposes for this separator? So you really have to think through the process, and I like to look at each of the unit processes and determine, can I make it more efficient, and if I can, how can I do that? And then what piece of equipment would be able to help improve with that? And here in this particular case, the thickening of the solids with the vibratory screen really helped for twofold in this particular case.
Mhm.
It was there for the anaerobic digester. It helped to reduce the amount of solids that were accumulating within the digester, and it also helped to thicken the solids to improve the performance of the screw press. So, yes, it can be incorporated, but again, it
Mhm.
depends on, do you have the place? Is it going to improve the performance of the existing system? And how will it be utilized? So there's questions you need to ask before implementing a technology such as this vibratory screen within an existing system.
Mhm. Right. Good point. Next question. What is the turnaround time for manure to enter the vibratory separation screen to then leave the screen as a liquid effluent?
Oh, now that's an interesting one. The thing is, uh, again, knowing the process, understanding um, what you're trying to do with the system. Uh, Really, by the time the material enters a screen, you're talking seconds. By the
Hmm.
time once the material hits the screen, it's vibrating very rapidly, and your solids are moving to your outlet ports very quickly. So the time on the screen is very short,
Yeah.
but getting it to that point, that could be the issue that takes time.
Hmm.
You have to do some pre-processing, such as they do on this particular farm, removing the sand prior to getting to the screen. Uh, again, it depends on, are we looking at the turnaround time, you know, prior to getting to the screen, or just the running through the screen itself. It's the screen itself is a very short period of time. Again, only seconds for it to do the processing there. But before and after, those could be considerably longer times, turnaround times.
Hmm. Hmm. Now you talk about the vibratory screen. It could be its own standalone practice, or it could be kind of a preliminary step to some of those downstream manure management technologies. So, what would be the significance of having core solid separation like a vibratory screen before other downstream management technologies?
Okay, and now I guess what I've seen in the operations that are using vibratory screen, I've seen it used in conjunction with other separation technologies. I
Hmm.
have not seen it as a standalone, not saying that it couldn't, but
Okay.
I've not seen it done that way. But
Right.
to get to your point here, it depends on what your purpose would be. Now, again, for this particular dairy, the one we did the evaluation on, they had the twofold purpose. They wanted to thicken the manure, thicken the
Hmm.
solids, because when you're doing a flush system, you have a very low solids content, and the performance of a screw press may not be as efficient as it could be. So by getting that solids content up to, closer to the 8, 10, 12% solids, that improves the performance of the screw press, and they were able to get better solids coming out. So that was one of the purposes of this. Also, removing the solids help to improve the performance of the anaerobic digester.
Hmm.
Now, the other side where I've seen things is that following your major solid liquid separation technologies, uh, this one particular dairy was using ultrafiltration. They had membranes, and they were having a plugging issue, specifically uh, hair from the cows and some of the other I guess solids that were getting through their primary separator. They were adding it to using this vibratory screen. It was helping to improve the performance of uh, their ultrafiltration system by removing those solids, so they didn't have to backflush their system, their ultrafiltration as often. So
Hmm.
it depends on again your purpose is. What are your goals? What are you trying to improve the performance of for those downstream technologies?
Hmm. Next question. The nutrient SIG evaluation was mainly focused on water quality, and several nutrients were sampled and analyzed during this study of the vibratory separation screen, including phosphorus, potassium, and various forms of nitrogen. So, what nutrients are of the most concern to farmers, especially regarding water quality, and why?
Well, again, there are the primary nutrients, which would be your nitrogen, your phosphorus, and your potassium.
Hmm.
Those are really the ones we focused in on. Not saying that the others not important, because they are important. You're looking at your
Yeah.
sulfurs, your magnesium, your manganese, all of
Hmm.
those others. They do play a vital role because they have an impact on your microbes, on the bugs that are in the soil that help with the soil health, the soil quality. But what we were looking at here, generally from a water quality standpoint, we're looking at the how can we reduce runoff,
Mm-hmm.
of nutrients. Also, how can we reduce the leaching of nutrients? And if we can see how we can remove or reduce those nutrient loads, that becomes a very valuable tool from the producer standpoint. Another area is we have many areas in the country that are very high in phosphorus,
Yeah.
and the nutrient loading from manure in most cases is not in line with the plant uptake in those areas. And
Mm-hmm.
what happens if you apply it based on nitrogen, generally speaking, you're going to over apply your phosphorus and you're going to begin to get a buildup of phosphorus.
Okay.
So, if we were able to separate out some of those nutrients to get closer to the plant uptake level, then we can do a better job with the land application of these manures to help I guess to reduce the potential for that buildup of those other nutrients.
Mm-hmm. Mm-hmm. Good point.
So,
Now, on the topic of EQIP, our last question here, does EQIP currently provide funding towards vibratory separation screen technology?
okay, here's another one of those. It depends. Okay, within each state, they have what they call payment schedules, and within those payment schedules, there's a standard called the 632 waste separation facility, and if they have a waste separation payment schedule, then they should qualify with a vibratory screen. But you'd have to talk with your local field office to make sure that they have that standard available. And I do believe most states do have a waste separation payment schedule, and they should be able to accommodate the this vibratory screen. But it does come down to there's a couple other things. Number one, do you have a resource concern? They will have to do that evaluation, determine if you have a resource concern, and that the waste separation would help to deal with that resource concern. And number two, do they have funding available? They do have limited funding within each county from an EQIP standpoint, but that is a couple of things that they need to look at. And does it meet? Does it as they rank within their county, where does their practice rank amongst all the other practices that people are requesting assistance for? So
Okay.
there's a couple of things that you have to think about when you're working with your NRCS with the EQIP as to where you would fit within there. Do you have a payment schedule? Do they have funding? And where do you rank within the system?
Okay. That's very helpful. Thank you.
Sure.
Well, with that, that concludes our Q&A session. Feel free to refer back to those resources slides and contact Nutrient for any follow-up questions you might have. Big thank you to Jeff for your valuable input regarding nutrient sig evaluation and broader insights into utilizing that vibratory separation screen technology to manage manure in a sustainable way. Jeff, is there anything else you'd like to say before we end the webinar?
No, I just want to say thank you for the opportunity to share, and I just think there are a lot of technologies out there, and they're constantly changing. And I know you're going to be you've already spoken about this, or you're going to speak about this on the resources that Nutrient has available. I think that there's some valuable resources available there to help you
Hmm.
with some of your decisions making as well.
Yes, definitely. All right. Well, thank you everyone for listening.